Okay, so again for today's session, you need to be familiar with join types. So let's go with the revision. So when do we use join? Or first, why do we need to use join for? For joining more than one table, right? Then we get to view a result combining information or data from more than one table. So join is a keyword in SQL to combine data from two or more tables based on related column between them. So we're gonna see how. In other words, we're looking for foreign key, right? When you need to combine, you need foreign key in order to define the relationship between the two tables. So the join operation is essential for retrieving and analyzing data from multiple tables in a database, and it allows you to create new views that contains the specific data that you need. Okay, so the basic idea is to match rows from one table with another, right, based on a set of columns. Usually we have the foreign key in order to define the relationship between two tables. So what are the types of join operation? We have inner join and we have outer join. Okay, outer join has many forms. We have left outer join, right outer join, full outer join. So let's try to understand by using an example the difference between the types of join. For inner join, this type of join only returns rows that have matching values in both tables. So if we have foreign key between in one table, then only we return rows that have a match between these two tables. Okay, so let's see an example. So here we have two tables. One is about, let's say, the employee or staff we have, and then we have faculty table, right? So in inner join, what we are looking for, we are looking only for rows that have matches between these both tables. So if we check here, we have Alice has faculty ID, right? And the faculty table, so it should show up here. For Bob, we have also a matching between the second table, then also should show up. Peter has no matching because his faculty ID is undefined, right? So in this case, Peter won't show up inside the result table. Finally, Charlie should be fine because he has a match into the second table. So in order to define inner join in your query, then you specify, as usual, we have select, then we have from employee, then we type inner join the second table. So this is the first table, comes after from close, then inner join the second table. And we define the relationship, how we are matching between these two tables based on the foreign key. So we have here foreign key, faculty ID. Then we say on faculty ID from the table employees should match faculty ID from faculty table. Okay? So we have to define the relationship between them. And we need to use inner join in this case. Okay? So this will result in one view, one table result where we have information. We got them from more than one table. Clear? Based on this example. So you must have a match when you use inner join. You must have a match. And one more thing, if you notice, since name appears in both tables as a column, right? So in order to distinguish between these two columns, I have to specify this name comes from which table and this name comes from which table. You have to. Otherwise, the optimizer or the engine of SQL will give you an error saying confusion. Which name you mean by this? So to clear this confusion, I have to mention the table name. Or you can define a qualifier to make it easier. Later we see an example when we start our practical. So this is for inner join. For outer join, combine also rows from two or more tables. But the difference is, if you check here, return all rows from one table and matching rows from another table. We're gonna see how soon. Even if there are no matches. So one table should show all the results in the result view and the matching ones from the other table. Now we see how based on the type of outer join. So we have left outer join, right outer join, and full outer join. Let's see an example, better than talking. So back to the same example we had. In this case, if I just change from inner join to left outer join, First thing you need to understand, when we say there's left and right, you need to identify which table is considered left and which table is right, right? Since we are using left and right, so we need to know which table is left, which table is right. In this case, which table has mentioned first? Employee. Then followed by lefter or left outer join, faculty. That means this is the left table, this is the right table. Clear? So between when we are mentioning the outer join, we are specifying left. Left means employee, the first one. The first table has been mentioned. Then this is the right table. Okay, now since we understood which table is left, according to left outer join, left, since I'm referring to left table, that means all data from left table should show up in the result, regardless whether some information in employee has matching or not. So since we said left, that means left table should show up in the result. Like this example earlier, Peter didn't show up in inner join. Now it's okay because he's in left table, even though he has no matching in the second table, but since we are using left outer join, so he has to show up. Clear? Right outer join is just the opposite. Same idea. Now the right, that means we are referring to faculty table this time, right? Then that means faculty table information should show up in the result, regardless whether we have a match on the left table or not. So in this case, the right table, faculty, has 4 faculty names. 3 of them has matching. If we look for science, engineering, sorry, only 2 of them. Science and engineering already have matching on the left table, but IT and business do not. But since we are using right join, then faculty table rows should show up in the result, must show up. So here IT and business had shown up, and we see that they have no matching on the left table. Clear? So here just the idea is you need to identify which table is left, which table is right. The full outer join means left and right. We need all information from both tables, from left table as well as right table. So in this case, all information will show up, and we will see like Peter, which was shown up earlier on left join, has shown up as well, and those based on right join also has shown up. So full means left and right. All information from both tables should or must show up in the result view. Okay? Any question? So these slides I already provided to you in PDF inside the team. You can download. Okay, now since you know what are or the types of join we may have, then let's start with our practical. So try to pay attention because it requires understanding. Okay, so the first one, everyone is ready, right? You have run SQL files, okay? Write query to retrieve student last name and first name along with each student advisor ID. Now for this kind of question, always it's good if you have the ERD. So I managed to find one. It's not completely correct. You can approach it also from MS Team. It's not fully correct. Actually, I found out some tables are missing and one table is incorrect. But this is the one I found available on the internet. So here we're looking for student information. So we have student, right? And the question is asking us to retrieve student ID, student last name, student first name. So these 3 exist in this table. So if you see, we have student ID, last name, and first name. That's fine. In addition, we need to show student advisor ID. So advisor ID is actually inside faculty. So if you check, we have faculty last name and first name. Okay, so this is actually, I don't know why they call it faculty. It should be like faculty member, probably. It would be more convenient. But anyway, so here we need to retrieve what? Only the advisor ID and last name. Okay, so we need to retrieve advisor ID and last name. Now, after we identify the right tables, we need to see how they are linked together. What is the foreign key? What is the relationship? So the relationship is we have faculty ID inside student table. Okay, so now we know how we can write SQL statement. So always you need to understand which columns you need to retrieve at which tables and what is the relationship. Once you know, then it's very easy, becomes. Then now we go to SQL, okay, and start writing. So we need select, we need student ID, Then we need student last name, last, S first for first name, and then what else? Now we need from faculty, we need FID, right? But FID exists in both tables, right? So now if we just type FID, let's type, always encounter the error. It's okay if you face an error, so you learn. So now we're gonna get error anyway, then we see why. Then we need also faculty last. From student, right? From student table. And then in this case, we need to use inner join. Okay? So we need inner join because we need matches between each student. The question doesn't say if it's null or not, so we assume it's inner. So just we type inner join and then faculty. On what basis they have a relationship? Based on what? What is the foreign key? What is the foreign key column? FID, right? So we need to use FID. FID equal FID. You should actually now anticipate some error already. Why? Because if you ask yourself which FID we are referring, is it from first table, second table, right? We're just typing FID. So now if I hit enter, I should get an error says column ambiguously defined, because he cannot recognize which faculty ID you are referring. Is it from student table or faculty table? So we need to fix this ambiguity. So we repeat again, select SID, S last, S first. Now for this one also it's good you clear the ambiguity. So we can say, well, this is from faculty dot FID. Okay. And then we need F last name, that's fine. Then from student, inner join faculty on, we need to fix this one too. So on student dot FID equal faculty dot FID. Okay? Now if we hit enter, we get the result. But it's not in good shape. Well, that's fine. So we can verify, we should get 6 rows. And the question here also shows 6 rows selected. Okay, so here is the comment. Now, if you like to simplify it a bit, instead of keep mentioning student and faculty, we can define qualifiers. Qualifiers are just simply like alias name to refer to each table. So we can give alias name to student table and for faculty table. So no need every time to write the table name in full. We can give an alias because especially when you have long query, qualifiers can make it easier to read. Okay, more readable. So how to use qualifiers? Simply again, we run the same query. And instead of typing faculty, I'm going to define qualifier F, the letter F referring to faculty table. So just simply I'm gonna type here F dot FID. Okay? Now soon you see how I'm gonna define the qualifiers. Then we need F last name. If you like to use qualifier everywhere, fine. Okay? But here just I used it for those ambiguous column. Then from student, I cannot go back. Okay, wait, just I need to repeat because I missed defining qualifier for, come on. Okay, fact. It shows the old statement, I'm not sure why. So again, this one, qualifier F, I'm gonna use. Then we need F last. Then we need from student. Then in order to give a qualifier name for student table, I put the table name, space, and you can give any qualifier. In my case, I'm going to give S. But it's up to you. You can define your own qualifier. So that means I'm giving like alias name to the table student. So no need every time to refer or to write the table name in full. Then I do the same, inner join. Then I give also qualifier name for faculty, F, because I have used F here, so I need the qualifier F. And finally on. Here, and instead of student, I can just type s.fid, and for faculty, f.fid. Okay? So this is by using qualifier. You can make the query more readable. Okay, same result, nothing changed. Okay, so this is option 1. There's actually another way to write the query as well. So let's see. Actually, there are 3 ways. Let's discuss about them since we're gonna use them later on, another example. So this is option 1. So this is from our previous session. I will share this file with you. So this is now what we have done. Now we have option 2. Option 2 is going to be same, this one. But instead of using inner join, we are just going to use from, and then we define the relationship like this. So we can say, okay, select, same, nothing changed. But we can put after from all the tables that we wish to use. So in this case, we have student table, qualifier S, faculty, qualifier F, and then we say where this time, where FID from student table equals FID from faculty table. So this is option 2. You can write. So you can, if you don't want to use inner join, then you can use this way. Okay? Clear? You want me to run? So it should work. I share the file with you, then easier. So same result. We have third option, which is special for Oracle. Since we define here inner join, right? Oracle offers us another way to write inner join by calling, or what's called natural join. So natural join is simply inner join, but it's easier or more compact in the sense that you don't want to define the relationship. You don't want to define the relationship. But then how Oracle will understand? You must have the same column name in both tables. Okay? Is it clear? Okay. So again, natural join just simply is an inner join. So you can use it in cases of inner join. You cannot use it for left outer join or right or full, only for inner join. But this one can just make it the query simplified. You don't want to mention the relationship. Oracle will check and understand how you're going to link between these 2 tables. Okay? So make sure you have the same name, same column name for both tables. Okay, so this is going to be option 3. Okay? Any question? So you have 3 ways to answer the question, unless the question specifies a certain way, like it says use inner join, or use natural join, or avoid using natural and inner join. Then you need to use this one. Now we move to question 2. Suppose you want to create a query that lists the last names of all faculty members who teach during the summer time. Okay, so now we know that the faculty members, we have faculty table, right? So we can retrieve all the last names, that's fine. But here we have a condition. Only those faculty members who are involved in teaching during summertime, 2007 in specific. So we need to know how we can identify the terms. So if we check back the ERD, we have term table. So in term table, we have term description. Term description involves the terms, the description of the terms, like summer 2007. You can check, always check, so you understand. Select from term. Okay, so we see that we got all the terms we have, including summer 2007. Right, so we need to retrieve only those faculty members who are teaching during summer 2007. Right? Okay, so now we identified the columns. So we need last name, faculty last from faculty table, and we need term description from term table. At least to apply where clause, right? We need to have specific condition based on term description. It should match summer 2007. But now the second thing we need to know to identify the relationship. There is no direct relationship between faculty and term. There is no direct relationship. So we cannot simply apply relationship between these two. Okay? So we need to understand how we can reach out to term. In order to reach out to term, if we check the relationship, term has been linked to course section. Right? So inside course section, we have term ID as foreign key. This one can help us to link to term table. And course section at the same time is linked to faculty. Where's the foreign key? The foreign key is in faculty ID, also inside course section. That means we need to involve these three tables. Okay? So clear, after you identify the columns, you need to retrieve, you need to identify the relationship, how you can link between these two tables. Since now we know, then we can write our query. Okay? So we need to say select. I'm going to use qualifier. So for faculty, I'm going to refer to it by f underscore last. Okay? And then what else we need? Only last and first. f dot first. Though it's not required here to put qualifier, but it's fine. If you repeat the qualifier in places that is not required, that's still fine. Okay? Now we need to use from. That's it. This is the only two pieces of information that we need to show in the result table. Now we type from faculty, F, right? Then what we need to do? Inner join. Inner join with whom? With which table? Which table should be linked to faculty first, according to this? Which table? Course section. Yes, correct. So firstly, inner join with course section. CS, I'm going to give qualifier CS for course section. Then we need to say on what basis? On f.f underscore ID equals cs.f underscore ID. Right? Are we done? No. We need a second inner join. So again, inner join. Which table now? We're left with term table. So we need to say term, T, I'm giving qualifier T as term table, for term table, then on. Now how term and course section are linked? Based on term ID, correct? So term ID exists in course section and in term table. So we need to say cs.term ID equal to t.term ID. Are we done? Not yet, because the question says only those who are involved in summer 2007. So we need to write where clause now. Where. Now which table we need to check against for the semester is in term description column. So we need to write where t.term description equal summer 2007. Correct? Now if we run, we should get the result. You can compare with the result here, which is correct. Okay? Any question? Now, if you wish to use option 2 without inner join, then also can. Same query. So this is option 1, we already done. Then option 2, you have from 3 tables, from faculty, F, course, section, CS, term, T, and then where, just we take the on condition. We have already defined F, same, nothing changed. So this one here, this one here. And finally, we have and term description equals summer 2007. Okay, so you have 2 ways. The third way, you can use natural join. Natural join only in Oracle. If you are using SQL Server, you cannot define natural join. You use only inner join or this option. These both are applicable. Any question? Okay, no question. Silence means agreement. Now suppose again that you want to create query to display the call ID and grade values for each for each of student Sarah Miller's courses. Okay, so only we need to retrieve the grades for Sarah Miller, okay, and the call ID. First, what we need to do, we need to identify the columns. Where are these columns located? Call ID and grade. If we check back the ERD, we can see there's enrollment. In enrollment, we have grade, right? So this is one of the column. And this one is linked to the student. So now we can know Sarah's grade based on her student ID, correct? So we need to get student. We find her student ID, and then we can get her grade. Now for call ID, we see that it exists in course table. And course table has no direct link to enrollment. So we have to go through course section, and then only we can reach to enrollment. So now how many tables are involved in this case? How many tables? 4, right? We have 4 tables, right? Can you catch? Good. Okay, so we have 4 tables. We need call ID from course, grade from enrollment, and student last name and first name to have the where clause for Sarah Miller, because we are only interested to show the grades for Sarah Miller. Ready? Okay, so let's go. Select. Now the output only required for us, we need call ID and grade. We don't need to show her name, but if you like to show, maybe just for testing to ensure your query is only about Sarah Miller, so then that's fine. You can add it, but let's say you can remove it later, just to identify that it's correct. For now, I'm not gonna do it, but just I'm telling you. So for call ID comes from which table again? From course. So I'm gonna give qualifier C for course.call ID. And also we need the grade. Grade comes from enrollment. I'm gonna give qualifier E, referring to enrollment. So E.grade. Now we type from which table we're gonna start, it's up to you. But I'm gonna start from student, then referring to enrollment, and then from enrollment to course section, then from course section to course. So I'm gonna start from student. Why we need student again? You need to ask yourself, why I'm involving student table? Why am I involving student table? Because I need, yes, I don't need last name and first name for the student to show up, but I need them to do matching because I'm looking only for Sarah Miller. So how can I write the where clause? I need to refer to student table to say only I'm looking for Sarah Miller, Miller as last name, Sarah as first name. So this is why student table is involved in this case. So from student S, inner join with with what? With enrollment. E, qualifier E. Make sure the spelling is correct because this SQL Plus is not so friendly. You have to repeat again. So inner join enrollment E. Then on S underscore ID equal, because here the foreign key is S underscore ID. So we need to use E dot S underscore ID. Then we need second inner join. The second table, now we need to link. Now we already have identified the relationship between student and enrollment. Now second inner join is going to be between enrollment and course section. So now join inner join course section CS on E dot what? What is the foreign key? If you see here, enrollment has course section ID. Course section ID. So I'm going to use course section ID, C underscore sec ID equals CS dot C underscore sec ID. Now we are done with second relationship. Now we need the third one. The third one is between course section and course. So again, inner join course C on C dot. We need to use course ID. Is it course ID? Yeah, course ID. You see the column, course ID. So we need course ID equal CS dot course ID. So now we have finished identifying the relationships between these two tables, 3 or 4 tables. Now we need where clause, because only we are interested to show the grades for Sarah Miller. So we need to say where. Now we are involving student table. Okay, so S dot first or S underscore first equal Sarah correct, and S dot S last equal Miller. Now we're done. You want me to enlarge the font? Better. Okay. And always try to make your query tidy. You see now how easy to read? If you put it all beside each other, it becomes like the barbecue stick. Then you won't be able to read easily. This one has made it more human readable. So make always your query easy to read. Yes, I'm putting more effort to write it nicely, but easier for me even in future if I need to do maintenance or checking for bug, easier for me to check and read. Okay? Now we run. We got the grades, the call ID, and the grade for each one. Okay, any question? Of course, you can also avoid inner join, same like option 2. You can list the 4 tables. So here also I already put option 2. Here, you need to involve all tables after from, and then you copy all condition, where the first, second, third relationship between the 4 tables, and then the condition to filter the student to show only Sarah Miller's grades. Any question? So this is the option 2. I'm gonna share this file with you. You can get it later. Or shall I share it now? But if I share it now, maybe you won't bother yourself to type anymore. Just copy paste. And I want you to build your finger muscles. You need to type. Okay, now we go to question 4. Any question? Okay. So we go to question 4. Write a query for the HR department to produce the addresses of all departments. Okay. use location and countries table. So actually those information are located in locations and countries. If you check the ERD doesn't show countries, and location table is wrong. So you cannot depend fully on this one. Unfortunately, SQL Plus doesn't produce ERD. If we are using like SQL or some tools, I'm not sure for Oracle, but in SQL Server Management Studio, it's easy, we can produce ERD at any time. ERD is very useful because now I don't need to search blindly for the information. Just I can check the diagram and see where the columns are located and the relationship to identify each two tables, between two tables. Okay, but for now, since we don't have, let's do some blind inspection. So we need to check location and countries. Let's check what do we have inside locations table and countries table. So select from locations. Let's just investigate. Table view does not exist. Location. Okay. So I have, if you like to see only the table, there are two ways, the column name, I mean. You can write here, how you can show one row only in Oracle. Do you know how? To show one row only. I don't need the whole result. Here I have 8 rows and made it difficult a bit to follow up. So I can type here where row number is less than 2. That means only 1. Then I get 1 record. Or you can use the other way, column name from user table columns where table name equal locations. Right? This is, we used it first time. So this also helps us to see the column easily. So now we need the address. If we check back the query here, we need to show location ID, street, address, and city. Okay, so location ID is here, street address is here, city is here. Also we need state province, also is here, state province, right? So we already identified this column. How about country name? Country name is not here, but we have country ID. So most likely we have countries, the information are inside countries table. So if we check again, same and say here, countries, then we see that I got country name here. Okay? So now I need to link between these two tables using country ID. Okay? So now we can start typing, select, we need location ID. So from this table, location, I'm gonna give qualifier L, location ID, L dot street address, L dot city, oh my god, now I cannot go back. I have to repeat. Okay, city. Then what else we need? State, province, also from location. Now we need country name from countries table. So I'm gonna call it C, qualifier for countries, dot country name. Now we're done. But this question is asking us to use natural join. So let's use natural join. So natural join, but first we need to write from, don't forget, from what? Locations, L, the qualifier, then natural join with which table? Countries, C. That's it. But here, since we are using natural join, the qualifiers I think are not permissible. We cannot use. So if we run, oh, it's work. Okay, because last time I tried, it didn't work. So that's fine. Now we got the result. We got 8 rows. So here also we should get 8 rows. Okay, so again, this is the query. This one. Okay? So we don't need to type on. Natural join will take care of that. So this natural join again is just inner join. It is just inner join.
has force. I copy the picture, the link to find the
Okay.
table. To see the table,
Here's a tab column
to see as this one. What?
where tab, what it says from keyword not found where expected. Select column name. Yeah, because this is not from.
Yes, I'm not on.
FR0M.
0 and
Yeah, it's wrong. It's from.
oh,
Just a spelling mistake.
you see, so it's what?
Yeah, from
FR.
OM. Yeah. Okay, try now.
Oh, where?
There must be just some typo. Yeah. Okay.
Say advert or some advert and he very identify, but I will give you find the advert.
Select. No, because here you put dot. Should be comma,
Oh, yeah. Oh,
right? Yeah. Try again.
But why teacher table with me is different? Teacher table have the.
No, that's
RT.
true. I'm not sure. Where did you get your SQL file?
Uh,
Because the ARD I have shows this information.
I insert.
No, not location. Locations.
Oh, SR.
Yeah. So try again. Okay. Okay, everyone. Anyone has question? Yes. Table or view does not exist because here you wrote counties. Counties should be countries, not counties. Yeah, just typo. You need to get used to the engine, or I mean the errors that you get from SQL. Okay, because he's trying to talk to you. Sometimes we don't understand what the machine is saying, but this is the only way we can communicate. So we need to learn their language. Okay, so now here we don't have option 2 because the question is saying natural join. So we cannot go with other options. Okay? Now question 5, the HR department needs a report of only those employees with corresponding departments. Okay, this is important actually, they're giving you a hint. So once you see such information, I mean, how to say, is not often to emphasize, then highlight. Only those employees with corresponding department. Write a query to display the last name, department number, department name for these employees. So let's see first where we can obtain this information. Last name for the employee, right? So this one comes from where? This is for HR department, the employee table. Remember last week we were working on employee, so we have last name. Let's find out how to get department because we never used department before. So let's check employee table. Okay, so if we check employees table, we have department ID. So now we know there must be another table for departments. So let's check. Okay, so here we got department name. So now at least now we know how to get last name from employee, department ID, and department name. That's all we need. The relationship is quite clear. We have department ID here, department ID here. Correct? So the relationship is clear. But now we need to emphasize on this. Only those employees with corresponding departments. What does it imply? What does this statement imply? Only those employees with corresponding departments. What does it imply? Ask yourself, what does it imply? What they're trying to tell you. Come on, anyone? What does this statement imply? Only those employees with corresponding departments? Anyone? No? Sorry, again? Just can you speak up? I cannot hear.
Let the worker do their work.
To?
To do their responsible work.
Meaning? Can you?
Do their own work.
Okay, but meaning in terms of join, what does it mean? Just we give him chance first. Wait. That means imagine the two tables you have. So they're telling you only those employees that you have from employee table have a corresponding department. Meaning?
They do.
Okay. Yeah, meaning same. I mean, what does it? How does it reflect my SQL? What does it imply? Okay. Yes.
Which the department they work.
Oh, yes, that's true. But I'm trying to emphasize why they mentioned this. Can be a trick, by the way. This is why it's a clue to identify the relationship, because they're talking about employees and department table. So they're giving you or emphasizing on one piece of information, that there must be a match between these two tables. So in other words, inner join, right? So always look for these clues, right? So they're saying only those. That means there must be a match between employee table and and department table. It's a must. And which relationship enforce such definition? Inner join. Okay, so be careful. These can be a trick. But good try. Try to catch, huh? Okay, so now we refer back, select. We need last name from employee, so I'm going to give qualifier E. Last name. Then we need department ID, so we can get it from department. So D, I'm going to give qualifier D. Department ID. Then D dot department name. Now we're done. Then from employees, E, qualifier E, inner join, departments, D, qualifier D, on, E dot department ID equal D dot department ID. Okay? Now we check. Here is the result. Any question? Okay, since the question doesn't say anything, so you have option 2. Again, I didn't mention here, but you already know. So you can use from statement, mention employee, department, then where, E dot department ID equal D dot department ID. Okay, so both ways are equivalent for inner join. Or you can use also natural join. So you have 3 ways to write your query. You have 3 ways. Okay, now we go to question 6. If you have any question, then just let me know. The HR department needs a report of employee in Toronto. Display the last name of the employee, job ID, department ID, and department name. So we already know where this information come from. Last name, job ID from employees table. Last 2 weeks we were working on it. Department ID, department name, just now we found we have department table, so we can use as well, right? And only the condition here, we need to ensure that those employees come from Toronto. So how to know where these employees are, or the department location? So we need to investigate a little more. If we check back department, do we have anything to refer to the location? For departments, we don't have. We have manager, we have location ID, all right? So if we check departments table, we have location ID. Let's check location table. This time I think it's just location, not locations. Location. So location, we have location ID, building code, room, and capacity. But I'm not sure where is Toronto in this case. So I need to check further. So I'm gonna type select from location. So we have no info about the location. Is it we need to use location or locations for this one? Because we have 2 tables. We need to use locations, not location. So location, we have, do you see here any Toronto? I think Toronto is the state name, right? Sorry? Anyone is talking? Okay. So what is it? Okay, do you see Toronto? Here, the city. So it's a city name. On the city column, we have Toronto. Okay, so that means we need to use locations. And inside location, we need to filter based on city column, only those departments that are linked to or under this city name, Toronto. So for locations and department, we already know. All right, there's location ID inside department. So now we have 3 tables. We have employees, we have departments. Departments is linked to location. So 3 tables we need to use. Okay, so back to the question. We need last name, job ID. So select E dot last name, E dot job ID. What else? We need department ID, so we can get it from department table. And then we need department name. From employee, employees, E, inner join. You should write it already fast, right? Inner join, we have departments. D, on E dot department ID equal D dot department ID. Then we need another inner join. We have locations, L on L dot location ID equal to D dot location ID. right? Now we still have where clause. We're not ready because only we need to show data for those departments in Toronto. Then where location L dot city equal Toronto. Toronto. Okay, so we got this information. Should be correct. So only two records. Two records. Okay, any question? If you like to use natural join, can ease you for Oracle. You can type here natural join. No need for this one. Then natural join this one. No need for this. And finally, you need where clause. Any question? Okay. If you need some time, you are writing or anything, you need to tell me. Because I don't know what you are writing. Huh? Maybe you are writing message, you are sending email, you're talking to your friend. Okay, now we need to go to question 7, which is a bit challenging. So please open your eyes and ears. Pay attention. So question 7 is about self-join. In other words, we're going to join the table by itself. Okay? So the question says, create a report to display the employee's last name, employee number, so far so good, along with manager last name and manager number. Now manager number easy, but manager last name. If we check employees table, select from employees, or if I use the command just to show, okay, so what we got here, employee ID, easy to get, right, not issue. Employee name, let's say last name. Then we need manager ID, we already have. But how to get manager name? How to get the manager name? Firstly, if we are looking to manager ID, do we have manager table to link? Actually, no. If we check here, you don't have managers. No such rows selected, nothing. Manager, also no. Okay, if we take further look, we're not yet finished investigating. If we check select dot from, let me take only employee ID, last name, and then I need manager ID from employees. Just this is for inspection. Select right? Now with little investigation, let's try to understand. For example, King has no manager. That's fine. He is the CEO or something, so he has no manager. He's the big boss. Then Koshar, he has a manager whose ID is 100. So who is he? Which employee hold the ID 100? Is King. You see? Because after all, the managers are employees as well. Correct or not? Managers, they're not coming from another planet. They are just simply employees, right? With a position of manager, managerial position. If we take another case, Dihan has manager ID also 100. That means also his manager is King, right? How about Hanold? Hanold has manager ID 102. So in other words, his manager is Dihan, right? We have here 102. So for Hanold case, his manager is Dihan, and Dihan manager is King, right? So we can see the hierarchy. There's hierarchy here. So same table. We're not referring employee table, manager table, director table, and then CEO also will have his own table. They are just one table. We put all data in. And we have hierarchies based on manager ID. So in other words, now later what we're going to do, we're going to link the table to itself again based on manager ID. So manager ID must be equal to employee ID. Correct? In order to get the last name, because I need to type later, and as a result in my query, for example, Hanold, his ID is 103, his manager 102, and the last name for the manager name is Koshar, right? Or Kochar. So I need to show this piece of information. So the idea is very simple. In any SQL, I mean any management studio or any database, you can come with or using self-join. So this is called self-join. So in other words, which one is my base table? So here is my employees table. Right? I have here the employee ID, and I have the manager ID, right? Now self-join, that means I need to join the table with itself. So now I'm referring this as qualifier E, employee. Again, the same table I need to join with. So employee ID, and then manager ID. So this one, when I do self-join, I can also give qualifier M. But this one is again employees table. It's not a new table. It is same table, but I'm gonna distinguish between these two by different qualifiers. So this is E, this is M. Fine so far? Now the only thing left to know how to link these two tables. This is very important. How to link these two tables? So here I'm gonna get employee ID and I need the last name from E table, the qualifier, right? I need these two information. I need also manager ID, but in order to get the last name for manager, from which table? From the self-join table. So last name should come from here for manager. Since I'm going to link these two tables, so last name in the second table should give me the manager name. So employee ID, last name, manager ID, then the last name from the self-join table. Clear? Just simply you are linking the table to itself. You are linking the table to itself. Okay? So in other words, like we are doing like this. So the relationship, the foreign key, instead of linking, if we are drawing the ERD, of course. Now this is for demonstration. But for ERD table, we have a single table. For the relationship, we can do self-link. That means we have self-join here. Okay? Clear? Now the condition. Because the identify, we need to link both tables, so we need to identify the matching. Matching based on what? The matching based on E dot, yes? Anyone's talking? E dot manager ID equal, we need the relationship, the condition, equal what? This is, right? So from employee, I need the manager ID should equal to what? Yes? The question not clear, right? So again, I'm saying employee manager ID should equal to what? Somebody was talking? Yeah, there, here. M dot? Yeah, correct. So M dot employee ID. Because the employee ID here should be the manager ID. Correct? I'm only matching between manager ID with employee ID. Again, same table. But the manager is simply another employee. So from the manager qualifier, I refer or match with employee ID. So whatever the employee says, this is my manager, I can check here based on the manager ID as employee ID to fetch his other information. Okay? Clear? This is very important. So always you need, if you don't understand when it comes, let's say later during exam time or you're doing your assignment, do like this and make sure the relationship you have highlighted. Because any changes, if you type here M, manager ID equal E dot employee ID, sorry, yeah, if you type here M, manager ID, E, employee ID is wrong. You get different result. So make sure you highlight the relationship, how you do self-joining. This table can be useful. By the way, many things can be applied for self-join. For example, if you are applying categories, and categories have subcategories. So there's hierarchies. So in this case, you identify only, you build one table, categories. Then you do the same thing. So let's say for category, if you have FYP projects, so now cheating time, not cheating, but just explaining time. So category, this is a good example where you need to do self-join. Another example. So let's say we have category ID, description, and then we got category or the parent ID, the parent category ID, because we have subcategories. So each category has parent, right? Like for example, we may have programming, which is parent, under maybe subcategories, maybe object-oriented, functional programming languages, and so on. So here we need to have parent. Parent, if you like to type category ID. Then this is again self-join, same idea. Okay? So you don't need to go build one table for category, another table for subcategory, and then another table for subcategory, and this never ends. You build one table and you identify hierarchies, self-join. Okay? So now we know what's going on. We have single table, that's all for our query. So we type select E. So always keep this picture in mind when you write. So we need to get employee ID, last name, and manager ID from qualifier E. So E, employee ID, but we need to have also here some alias because it says label the column employee, employee number, manager, and manager number. So let's follow the same. So we're going to show first last name, and the alias name is going to be as following the question. All right, employee. Then E dot, we need to show the employee number as employee number. Then what else we need? We need the manager ID. So we can also get it from E, or before manager ID, we need the manager name. So in this case, I need to refer to which qualifier to get the manager last name? Check the picture, the illustration. Which table, under which qualifier I need to retrieve the manager name? Is it under E or under M? Under E. Any second opinion? Actually, I gave this qualifiers on purpose. I gave this qualifier E for this table and M for this table, M referring to manager. So here I'm going to have the manager information. Here I'm going to have the employee information. Both of them are employee, but just to distinguish between them. So the last name should come from qualifier M, not from E. Okay, you got second one. So now we need to type M dot last name as employee, as manager. Now what else left? We need the manager ID. Now here it should be up to you. Either you can take from manager employee ID or from employee manager ID. Correct? The manager ID, either you can get it from M, employee ID, or from E, manager ID. Right? So it's up to you. I'm going to put M dot employee ID. But again, this is one option, or you can type E dot manager ID. So you need to be careful. This is why you need to draw this picture before you answer the question, so you know where the columns come from the main table or the self-join table. Okay? So if you type E, then you need to use manager ID. If you type M, then you need to use employee ID. So be careful. This is why I told you this question is challenging. So this one we need to name as MGR. Okay? Now the rest is just same. So now we say from employees with qualifier E, then inner join. Inner join with which table? Inner join with which table? With the same table, again, employees, with itself, under qualifier M. On. Now this is why I told you to highlight the condition. It's very important. So following that, what we wrote on the board, we follow exactly. E dot manager ID equal to M dot employee ID. This is why this is very critical. This one. This is all kind of okay. We understand we need to self-join with the same table. Nothing challenging here. But the challenging part is this and this. These two. So it's very important or even crucial to draw the pictures first. Only then you identify the relationship and where the columns are coming from the main table or self-joined table. Now we're done. If we hit enter, then we should get the correct result. So we should get 21 records. So we got 21 records. If we look, so now we have Kochar has the manager King, right? How about this guy? So this guy also has King, correct? Do they ask us to order by? There is no order by because seems the data not in the correct sequence, but that's fine. We can still check. Take another example. Here we can see Taylor. Where's Taylor? Taylor. His manager should be Zlotki. Taylor. Yes, correct. And his manager ID is 149. Okay? So we can do verification. Any question? Any question? Then if no question, we move to question 8. Question 8 is easy. Modify the query in question 7. That's nice. That means we already have the query in place. Just do some changes. To display all employees, including King. Because if we check back, King information is not here. Why? Why King didn't show up here as an employee? He has been shown as manager, but not as employee. Why?
He's manager.
Yeah, meaning
Yeah, boss.
he has no boss. And how this has been affected on the result? Because we are using inner join, right? So always you need to have full understanding for the question. So now we have inner join. King didn't show up here because remember inner join must have full match. Must have a match between these two. King is here, yes, but if you check, King has no manager ID. So we cannot have a match with manager table. Correct? If you don't believe, check. Always don't take my words for granted. Go and explore. I'm not going to be with you when practical tests come. All right, so you need to explore. If you're not sure what we're talking about, then explore. Oh my God, what else? If we check King, King has no manager, right? So since we are using inner join, so King is here, fine, but he has no match in manager table. And since we are using inner join, then his information as a normal employee won't show up. But as a manager, yes, because he is manager for other employees. Okay? So now what does it imply? Since it asks us the question to display also including King. So King information is here. As a result, we need to show King ID and King last name in the last query here. So now what type of join we need to use? We need to change from inner join to? No, you said something. What? Outer join, yes, but which one? We have 3 types of outer join. Is it left, right, full? Left. Okay. Who said right? Left or right? Both? No, you need to ask yourself where King information. Yes, he's here. Sorry? But we need to show him as normal employee on the left because we're using e.employee ID, e.last name. So we need to ensure that he's on the left side, right? And I know you said correctly. Just have enough courage to say it. No worries, even if it's wrong. Okay, so now here what we need to do, going back to the same query. Where is our query? Here. So we need to come here and use left. Okay? Left. Right? Again, if you like to have more convinced why left, not right, because King should show up here under E, which is left. M is on the right. Right? So this is left, this is right. So left join employees, and then on, the condition is same, no change. You don't change the condition. And then we see King has shown up. But he has no manager. Okay? Clear? Actually, even if you use full, join should be correct. But let's just focus on this because it's impossible to have manager without having employee or subordinates under him, right? But anyway, we just follow the basic understanding. He has to show the information on under employee, then we use left. Okay? Any question? So the changes for question 8 is just this one, from inner to left. That's it, same query. No changes. No other changes. Okay, now we move to question 9 and 10. I think they are easy, should be. Display the student ID, first name, last name, and grade of student who scored an A for the course of database management at the Northwoods University. So student ID, first name, last name, we know where it comes from. We have student table. Grade, from which table? Enrollment, right? We already applied the query before. The grade comes from enrollment. And then for the score, that's easy because we can depend on grade. For the course, now this is new. The course of data management. So now we need to link student table, enrollment, correct? Course section and course because we need to check the course name. So if we check back the ERD, we need student, enrollment, we need course section and course because under course, we have the course name. Then we can filter only those courses of database. Clear? So if you like to take the old query, I'm not sure which question was, and then probably just do some modification, but we don't need term. I think we can start. Which one? Faculty, we don't need faculty. I think this is the closest one. So we can take this one and modify. Can take this one, but I need only this one. But do we need to show last name, first name, what else? I think just let's write it again by ourselves. Easier. So select. We need student ID, first name and last name. So from student table, qualifier S. Which one first come? S, ID. Then S, first name. Then S, last. And then we need the grade as well. So the grade comes from which table? Enrollment. So qualifier E, grade. Okay, then from student or students? Student. S, we need inner join with course, with enrollment. E, on. S dot S underscore ID equal, is it SID? Yes. E dot S underscore ID. Then we have another inner join. We need course section. CS on CS dot course C underscore sec ID equal to E dot C underscore sec ID. Inner join. Finally, we need course C on C dot course ID equal CS dot course ID. Are we done? No. We need where clause. Where course dot course description. Course. We need course name. course name equal, what is the course name? Database management. Okay, I think now should be fine. Not yet. Also, we need only those who scored A. So we need to have and. A grade is under enrollment table, so E dot grade should equal A. Okay, so here we got single student, Brian Yumato, he got grade A. I think he's Japanese student. Any question? So now you become expert in inner join. But if you like to use natural for Oracle, easier. So I'm giving you the difficult one, how to write, then natural join should be easy. But it's good you practice on both, because you might be asked to use natural join. So at least you know how to use natural join. You like to try natural join for this? Do you like to try natural join? No? Feels headache? You need CPU fan. Next time install fan here. Then question 10, modify question 9. These are good questions. It's just small changes and easy to do. To display the student ID, first name, last name, and grade of student who does not score an A. The opposite. Same question, but this time is just the opposite. Here we located the student who attended database management who scored A. This time we need to find the students who attended database management but didn't score A. That mean anything else. Maybe B, C, F failed, I don't know, but just he didn't score A. So same query. This is the good news. Right? Same query. But how to say doesn't equal? Because we need to say doesn't equal A. If you don't know, then you need to say grade equals B, or grade equals C, or grade equal F, or grade, you need to keep repeating by or. But the easy way, just you can say doesn't equal. So for doesn't equal, you have two ways to say it. Let's write the query first. Not employee, we need student. Okay. Here, no problem. Here, the last one. How to say doesn't equal? Or you have a third option, as I said, you need to type here. You need to put parentheses saying E grade equal B, or E grade equal C, or E grade equal F, and so on. But if we need just to say doesn't equal, we have two ways. You can use the symbol like this. This means doesn't equal. Or you can use like this. Less than, greater than. This also means doesn't equal. So use either one. So let's try the weird one, which is less and greater. Okay? So Sarah Miller has scored B. By the way, also Visual Basic 6, if has anyone used it before, same way. We say doesn't equal, less than, greater than. Any question? So by this we have ended our practical session. Any question? Easy? Yes.
My current one is very defined. Yeah, many questions.
Column ambiguously defined. Because you said SID. So SID comes from which table?
Student.
Yeah, so you need to say. Because SID exists in many tables. E. But this SID comes from where?
Oh, so we want to put
Qualifier.
export.
Yes, you need qualifier.
Oh.
Yes. The file? Yeah, can. Each one 5 ringgit, huh? Okay, so here the file, question 10. Yeah, so you can use this, same also. Okay, go to your shared folder and on your desktop. Go to your desktop, there's shared folder. Where's the file? It said copy. I think it went to some folder. To share folder, okay. So inside shared folder, you have oracle.sql. You can copy to your side. Any other question? Anyone wants to scan his QR?